morning, students. In this session, we are going to discuss a new chapter called hydrogen. As we know, hydrogen is the first element of the periodic table and it is the lightest element. This hydrogen exists in two forms, that is, one is atomic form and other one is elemental form. This atomic form exists only at higher temperatures as H11. In this elemental form, hydrogen exists as a diatomic molecule as H2. This is about the brief introduction to hydrogen. Now, let us consider the position of the hydrogen in the periodic table. The position of the hydrogen in the periodic table is quite controversial as it resembles both alkali metals as well as halogens. Now, look into the resemblance of alkali metals with hydrogen. Firstly, when you observe the electronic configuration, when you consider the alkali metal as sodium, its atomic number is 11. Therefore, its electronic configuration is 1s2, 2s2, 2p6, 3s1. And hydrogen, atomic number 1, therefore 1s1. When you observe the outermost shell, both these elements possess only one electron in their valence shell. Therefore, the electronic configuration of these two elements are similar. Therefore, alkali metals and hydrogen will resemble in their electronic configuration. Now, let us consider the another resemblance, that is electropositive character. As we have observed, these two elements possess only one electron in their valence shell, that is alkali metals and hydrogen. These have tendency to donate only one electron. As it is possessing only one electron in their valence shell, these two have tendency to donate one electron from their outermost shell. This is about the electropositive character of hydrogen as well as alkali metals. Nextly, the oxidation state. As they are possessing only one electron in their valence shell, they donate only one electron. After losing one electron, the oxidation state possessed by both alkali metals as well as hydrogen is +1. Finally, both these alkali metals as well as hydrogen acts as a reducing agent. As we know, what do you mean by reducing agent? The species which reduces the other species by itself undergoing oxidation, as these have tendency to lose electrons, these acts as an reducing agents. These are some of the resemblance of the hydrogen with alkali metals. Now, let us look into the resemblance of hydrogen with the halogens. Firstly, the first resemblance is electronic configuration. When you observe the electronic configuration of halogen and hydrogen, firstly let us consider the halogen as fluorine and hydrogen. As we know, fluorine atomic number is 9. Therefore, electronic configuration is 1s2, 2s2, 2p5. And when you consider hydrogen atomic number is 1, therefore 1s1. You can observe the valence shell. Both the valence shell has one electron less in order to attain noble gas configuration. What do you mean by noble gas configuration? That is octet configuration, NS2 NP6 configuration. Both hydrogen as well as halogens have one electron less to form octet configuration, that is noble gas configuration, that is NS2 NP6 configuration. Nextly, the oxidation state. Both hydrogen as well as halogens possess -1 oxidation state. That is because both have tendency to accept one electron. Both these have possessing -1 oxidation state. Finally, the atomicity. Both halogens as well as hydrogen exist in the diatomic state, like hydrogen molecule, Br2 bromine molecule, I2 iodine molecule, F2 fluorine molecule, etc. The atomicity of both hydrogen as well as halogen is 2. The number of atoms present in a molecule, that is 2. Both hydrogen as well as halogen possess 2 atomicity, that is both exist in diatomic form. These are some of the resemblance of hydrogen with halogens. Due to this resembling characteristics of hydrogen with alkali metals and halogens, the position of the hydrogen have become quite controversial. So, hydrogen has been placed separately in the periodic table. Now, let us look into the next concept, that is the isotopes of hydrogen. Firstly, what do you mean by isotopes? Isotopes are nothing but the species having same atomic number but different mass number. So, hydrogen exists in 3 isotopic form, that is H11, H12, H13. This H11 is known as protium, H12 is known as deuterium, H13 is known as tritium. This protium exists in abundantly in nature, therefore it is used in many aspects. H12 is known as deuterium. It is used in heavy water which has been used in nuclear reactors. H13 is a tritium which is a radioactive element which emits beta radiations. These are about the isotopes of hydrogen, mainly 3 isotopic forms. Now, let us move on to the next concept, that is hydrides. What do you mean by hydrides? When hydrogen combines with any other element, it forms binary compounds. These binary compounds are nothing but hydrides. These binary compounds are known as hydrides. This is represented by MHX, where this X represents the number of hydrogen elements. Simply, what do you mean by hydrides? Hydrides are nothing but the binary compounds. Usually, the oxidation state of hydrogen in this hydrides is -1. As it is combining with the other elements, the usual oxidation state of hydrogen in the hydride form is -1. These hydrides are of 3 types, that is ionic hydrides, covalent hydrides and metallic hydrides. Now, let us look into the first type of hydride, that is ionic hydride. As we know, the ionic compounds are formed by the transfer of electrons. Similarly, these ionic hydrides are formed by the reaction between hydrogen and S block elements. Reaction between hydrogen and S block elements. As we know, alkali and alkaline earth metals are known as S block elements. How the ionic hydrides has been formed? These ionic hydrides has been formed by the complete transfer of electron from the S block elements to the hydrogen. By the complete transfer of electron, these ionic hydride has been formed. Example, sodium hydride, potassium hydride. You can observe here, in all these hydrides, the oxidation state of hydrogen is -1, both in sodium hydride as well as in potassium hydride. As the characteristics of ionic compounds is similar to this ionic hydrides, some of the characteristics of this ionic hydrides are, these are stoichiometric hydrides, these are crystalline solids, that is the physical state of this ionic hydride is in a crystalline form. These possess high melting and boiling point. They conduct electricity in the fused state but not in the solid state. As the ionic compounds also conduct electricity in the solution or in fused state but not in the solid state, these ionic hydrides are also conduct electricity in the fused state. These ionic hydrides used as the solid fuels. These ionic hydrides are used as the solid fuels. This is about the ionic hydrides. Now, let us look into the covalent hydrides. As we know, what are covalent compounds? These covalent compounds are formed by the sharing of electrons. So, these covalent hydrides are also formed by the reaction between hydrogen and p block elements. The reaction between hydrogen and p block elements leads to the formation of this covalent hydrides. This covalent hydrides furtherly classified into 3 types, that is electron deficient hydrides, electron precise hydrides and electron-rich hydrides. Firstly, what do you mean by electron-deficient hydrides? These are the hydrides which has less number of electrons in order to form covalent bond. Andre, let us consider the example B2H6. B2H6 is known as diborane. When you consider the diborane, this is the structure of diborane. As we know, the boron consists of 3 electrons in their valence shell. Both these boron consists of 3 electrons in their valence shell, and hydrogen has 1 electron in their valence shell. Therefore, these will form bond like this. You can observe here, in between 2 boron atoms, we need to make a bond, but there is no electron. In order to form bond, there is a requirement of electron. So, this hydride is known as electron deficient hydride. Why? There is a less number of electron to form covalent bond. When you observe the diborane, there should be a bond between boron and boron. But in order to form a bond, there is no electron. So, it is known as electron deficient hydride. Next, let us move on to the electron precise hydride. As the word itself says, precise means these hydrides has required number of electrons for making covalent bond. For example, when you consider the methane, carbon has 4 electrons in their valence shell. When it forms bond with hydrogen, as hydrogen possess 1 electron in their valence shell, they form covalent bond. They have required number of electrons to form covalent bond, that is electron precise hydrides. Finally, what do you mean by electron rich hydrides? As the name itself says, electron rich means after forming hydrides, in order to form covalent bond, they have electron rich species. These hydrides are electron rich species. That means after bond making also, some of the electron remains as the lone pair. For example, ammonia and water. In ammonia, you can observe 2 electron here acting as a lone pair. In water, the oxygen has 4 electrons which acts as a lone pair. This is about the covalent hydrides and its types. That has 3 types: electron deficient, electron precise and electron rich hydrides. Electron deficient means these hydrides has less number of electrons to form covalent bond. Electron precise means this has required number of electrons for making covalent bond. Finally, the electron rich hydrides means these have more number of electrons in order to form the covalent bond. Finally, the third type of hydrides is metallic hydride. What do you mean by this metallic hydride? Means this metallic hydride formed by the reaction between hydrogen and D and F block elements. The reaction between hydrogen and D and F block element is known as metallic hydrides. You can observe here the hydrogen occupies the interstitial site of the metals. Andre ಲ್ಯಾಟಿಸ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಹೋಗಿ ಹೈಡ್ರೋಜನ್ ಕೂತ್ಕೊಳ್ಳುತ್ತೆ. ಅಂಥ ಹೈಡ್ರೈಡ್ಸ್ನ ನಾವು ಮೆಟಾಲಿಕ್ ಹೈಡ್ರೈಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಆಸ್ ದಿ ಹೈಡ್ರೋಜನ್ ಆಕ್ಯುಪೈಸ್ ದಿ interstitial sites, these metallic hydrides are also known as interstitial hydrides. For example, titanium hydride, cerium hydride, that is TiHCeH. These metallic hydrides are known as non-stoichiometric hydrides. These are some of the types of hydrides, that is 3 types of hydrides: ionic hydrides, covalent hydrides and metallic hydrides, and their brief summary. This is about the hydrides. In the next session, we are going to discuss about the water, its